All right, so let's get going on today's class. So before we begin, just mention that we have a special guest with us today. This is my daughter Isabella, and she is here on Thursday. Is take your child to work day, but there's not a lot of classes going on, so we jumped the gun. We brought her here today. She just got done helping me out teach my first class, cognitive psychology. So she's going to be taking a little bit of a break right now and just sort of sitting back, relaxing, and learning about ANOVAs. All right, so before we get to that, just want to make sure everybody is aware for the final exam what's happening. So the final exam is going to be on Tuesday, April 30th. So we got a week before the final exam. It is going to be just on confidence intervals in Chapter 10. So it's not cumulative in as much as a stats exam can be non-cumulative, but it's only going to cover confidence intervals and Chapter 10, which is ANOVAs. So once again, it's going to be a computational exam. We'll do it exactly the same way. It's the final exam, but it's really exam 4 in nature. So it will be available on Canvas. There is 7-ish questions. I'm finalizing it right now, but it'll still be open book, which we know means open everything except other people. So once again, bring any notes that you might want. Bring any sort of guide. You'll have access to Canvas. You'll have access to your textbook. You'll have access to Google. Basically, any resources that you need to get the job done. It just needs to be your own work, so you can't do other people. We'll do it in class during class time, and that will be on the 30th. All right, before that, we are going to have a review session on Thursday, April 25th. So this is going to be an open review session. It's going to be student-driven, and as before, it is optional. So if you feel that your time would be better served preparing in another way, feel free. But I will be here to help anybody that wants to attend this review session. And just to be clear, this is actually happening after classes end. I don't want anybody to be confused and show up on Thursday looking for their other classes. So this is just a little extra thing that I think is really important to do. So that's why I've scheduled a review session. But just note that classes do end after the final class on the 24th. So there are no official classes scheduled for Thursday. But just so that we can have that review session, I'll be here. Actually, we'll be in the other room. And we'll have an open review session. So come on by if you want to see something one more time to get yourself ready for the exam. Any questions about the exam or the review session? Yep.
Not necessarily that, but do you expect to have grades updated before the final?
Yes. Yeah. Any other questions? All right. So today we're going to wrap up our introduction to statistics by taking a look at ANOVAs. And again, the question that we're going to look at, we're going to try to answer, was about comparative psychology, animal psychology. Specifically, why is it that some birds exhibit the behavior of migration, migrating massive distances, nearly killing themselves, in order to find a new place to live for the spring or the winter, and why do other birds not migrate? So one of the proposed theories was that, well, maybe it has to do with the intelligence of the bird. Maybe it has to do with the fact that intelligent birds can survive the winter. They have the strategies in order to hide food, find food. They're basically smart enough to survive the winter, but less intelligent bird species with smaller brains cannot do that, so they have to resort to migration in order to survive. So that's the question we're going to take a look at today and see if we can use, again, statistics to shed light on whether bird intelligence has anything to do with a bird's requirement or behavior of migration. So we're going to take a look at how to run an ANOVA in SPSS. We'll talk about the final homework assignment, and then because we got that exam coming up, I'll just alert you to a couple of weirdness with the due dates, and that will be it, and we'll have time for some extra practice. All right, so independent means ANOVA. We introduced it last time. Let's apply it this time around. So I'll read the description. So it goes, one possible explanation for why some birds migrate and others maintain year-round residency in a single location is intelligence. Specifically, birds with small brains relative to their brain size are simply not smart enough to find food during the winter and must migrate to warmer climates where food is easily available. This was a study done by Sol. You can check out the original study. It's in Canvas. Birds with bigger brains, on the other hand, are more creative and can find food even when the weather turns harsh. Following our hypothetical data similar to actual research results, the numbers represent relative brain size for the individual birds in each sample. We're going to use an ANOVA with an alpha of 0.05 to determine whether there is any difference, any significant mean differences among the three groups of birds. So we have three different groups of birds. It's an independent means ANOVA. It's the only ANOVA we're going to introduce in this course, but just so you know, this is an independent means ANOVA because we got three independent samples. So we have one group of birds that are non-migrating. We got one group of birds that migrate short distances, and we have one group of birds that migrate long distances. And the fact that we are looking at three populations means that we have to use an ANOVA. If we just had non-migrating versus migrating birds, we could do this with a t-test. But we want to investigate non-migrating versus short distance versus long distance. We want to investigate 1, 2, 3 levels. That's when we need to start doing an ANOVA. So those are the relative brain sizes for the birds that are non-migrating. So bigger numbers mean higher brain sizes compared to the size of their body. So that's for non-migrating birds. We got 6 birds. We got 6 short distance migrating birds. There are their brain sizes right there. And then finally, we got 6 long distance migrating birds. And there are their brain sizes right there. So we're going to ask ourselves, we're going to take a look at whether or not these samples indicate that the populations that they came from are significantly different. There actually are differences in the brain sizes between non-migrating short distance and long distance migrating birds. All right, so doing an ANOVA hypothesis test is going to be very familiar because once again, we are doing the exact same 5-step procedure, just a couple of tweaks, but the logic is still the same. So step number 1, we restate the question as a research hypothesis and a null hypothesis about the population. So we want to know, do birds that migrate shorter distances have bigger brains? We basically want to know, is there a difference in the sizes of the brains of these birds? So we got to restate the question as a research hypothesis and a null hypothesis about the population. The null hypothesis here, one of the things about ANOVAs is that they are two-tailed in nature. They're always going to be stated in a two-tailed way. So the null hypothesis is that the brain sizes are not different for birds that migrate different distances. The null hypothesis is that there's no difference. And that one we can actually write out mathematically. That one is written out by saying that the mean brain size for non-migrating birds equals the mean brain size for short distance migrating birds equals the mean brain size for long distance migrating birds. All the brain sizes are the same. All the mean brain sizes are the same. That's the null hypothesis. The research hypothesis, on the other hand, is the complete opposite, as before, of the null hypothesis. The null hypothesis is that all of the brain sizes are the same. The complete opposite of that is the research hypothesis, that at least one brain size is different for birds that migrate different distances. So we state the research hypothesis like this because mathematically it's a mess. If we were to write this out, we would have to say the research hypothesis is that non-migrating birds do not have the same brain size as short distance migrating birds. Non-migrating birds do not have the same size as long distance migrating birds. Short distance migrating birds do not have the same size as long distance migrating birds. Non-migrating birds do not have the same size as short distance migrating birds, but do have the same size as long distance migrating birds. We would have to do every single combination. What this does is in one sentence, it basically says, opposite of the null hypothesis, at least one brain size is different. So it could be one brain size is different, it could be 2 brain sizes, it could be all 3. We don't know, but at least one of them is different. That is the research hypothesis. And we state that as an English sentence. All right, next, step 2, determine the characteristics of the comparison distribution. SPSS will do this for us. And luckily so, because once you enter ANOVAs, degrees of freedom get very complicated to calculate, especially in the more complicated ANOVAs. So thank goodness SPSS will do this for us. Set a cutoff probability, step 3. For that, once again, it's alpha. So for your cutoff probability, it's still alpha. We don't mess with that. Alpha in this case equals 0.05. And then finally, step 4, we need to determine or penultimately, step 4, we need to determine our sample's probability on the comparison distribution. Once again, we're going to be reading it off as a p-value, and SPSS will provide that for us as well. So at this time, if you haven't already, open up the practice Excel sheet 31, practice April 2nd, chapter 10. And if you also haven't, open up your SPSS. As usual, there are screenshots that'll detail everything that we're going to be doing, but let's do it live as well. So what we're going to be doing is, again, the practice, whoops, wrong practice, the practice sheet right there. And let's zoom in on the bird brain data so that we can see that a little bit better. All right. So there's the bird brain data. We have our null research hypothesis done. So the next thing that we need is step 2, which is our comparison distribution. So for step 2, we're going to need the degrees of freedom between, and we're going to need the degrees of freedom within. Step 3 is our alpha level. We already got that, that's 0.05. And then step 4 is our p-value. And I'm also going to show you the F statistic, which is directly tied into that p-value, much like in a t statistic. It determines the p-value, the F statistic. I'll show you where to find that as well. All right, so we have our birds. We have our raw scores here. We got SPSS open. First thing we want to do is we're going to take the non-migrating birds and we're going to put those into SPSS. So we can highlight those scores and then we go to SPSS. Whoops. All right, so we go to SPSS. We copy and paste those in. And let's just call this brain, so that we know the brain, it's the brain size. So we go to variable view, we put in brain. So we have the non-migrating birds and we have them in terms of their brain size. So this is an independent means ANOVA. What that means is that these birds, these 6 birds here, they are separate. They are independent of the other sample of birds. So what we need to do is we need to kind of plan ahead and we need to say to ourselves, all right, when we go to this next series of birds here, we are going to copy and paste those and we're going to paste it directly underneath the scores for the brains that we have right now. We're going to copy and paste it directly underneath because these 6 birds, they're different birds. They're different subjects. They get their own rows. But before we do that, we need to label, no you don't. Before we do that, we need to label what this group is. Now this was the non-migrating birds. And you would think, and you would be wrong, so don't do this, but you would think that we could just put in, let's call it non-MIG, right? We're going to call this group non-MIG. And we'll name that non-migrating, non-MIG, non-MIG, non-MIG. And that'll be the one for the non-migrating birds. Then we could go short MIG for the short migrating, long MIG for the long migrating. We could do it that way. As it turns out, this is the way we did it for a t-test, right? Remember we had our group names and we had to define groups. As it turns out, for some reason, and I can only think it's this 1990s programming roots, SPSS will not allow you to label your groups in an ANOVA with words. Don't ask me why. It's just the way that it is. So we're going to have to play SPSS's game. We can't call it non-MIG. But what we're going to call it is we're just going to call it group 1. So put down a column of 1s. We're going to go to variable view and rename that as group. and we're going to call it group 1. And again, why are we doing it this way? Why is this programming archaic sort of, holdover still in there? I don't know, but we need to do that so we can analyze it. So we're going to call it group 1. So we now have our non-migrating birds. We've labeled them as group 1. The last thing we're going to do before we do anything else, before we put in any other information, there's a way to do this in SPSS, but I'll show you the simpler kind of way to do it just so we're not overwhelmed with steps. The last thing you want to do is somewhere make a note of which group is which number, because your human brain is designed to forget that information, and it'll basically, you'll have to do mental gymnastics later on if you don't do this. So just somewhere put 1 equals non-migrate, and that will help you jog your memory later on. So I highly recommend this. 1 equals non-migrate. You might say to yourself, oh, I'll totally remember that. And, you have about a 90% chance that you will, but you also got that 10% chance that you'll make an error. So just write it down. 1 equals non-migrating. All right, so now we're ready to do the short distance migrating birds. So we copy their scores, we copy their brain scores. Remember, in SPSS, they get their own rows. These are new subjects, separate subjects. They get their own rows. So we are going to paste those into their own rows right there. There we are. And then we're going to label this, the short migrating birds, as group 2. Okay, so once again, we got the short distance migrating birds. We put those into SPSS. We label them as group 2, and we make a note of that somewhere. So group 2 equals short distance. All right, and we got a group 3. So while I'm here, I'll just write it out. Group 3 equals long distance. All right, and we got to do it one more time for group 3. So we go back to our data. We copy the brain sizes for group 3. We pop that into SPSS. Once again, these are different birds. They get their own rows. So we pop those right there, and then we label them as group 3. And we are done formatting our data for SPSS. All right. Okay. So what we're going to do now is we're going to do the analysis. So for the analysis, once we got our data formatted, for the analysis, we go to Analyze. We go to Compare Means. So very nicely, we are still in the same file, subfile category that we were in for all of our hypothesis tests. So very nicely, we're still there. We go to Compare Means, and we're looking for an independent means ANOVA. And lo and behold, SPSS has, again, being very friendly, an ANOVA there, one-way ANOVA. That's the one we're looking for. So that one-way ANOVA is the independent means single factor ANOVA that we're doing today. So we click on that, and we put into our dependent list. Your dependent list are your scores. So in this case, it's our brain scores. So in the dependent list, we put our brain scores. And then in the factor list, we put our group numbers. And you'll notice that SPSS is not asking us to define our factors. SPSS just says, pop in your factors, pop in your group names. So that's what we do for that, that window in the wizard.
Why is yours? What did mine go into?
So what happened with yours is it thinks it's a word.
Yeah.
It's probably because you have it in there. Or so you should be able to use that. All right. So the last thing that we're going to do, or actually the next thing we're going to do, is we're going to go to options. And one of the things about an ANOVA, we're now getting to the point where things can get rather complicated. So whenever things can get rather complicated, there's a bunch of tests that you can run depending upon the situation. And you never want to click on everything. Because if you click on everything, you're going to end up with 80 pages of output, and you're going to have to go on an expedition to try to find your information. So what we want here is we want these descriptive statistics. And that's it. We just want the descriptive statistics. We just want that table that allows us to double check to make sure that we gave SPSS that correct information. So we're going to hit continue there. And then the last thing that we're going to do is we're going to click on this post hoc analysis. And the post hoc analysis here, we're going to not click all of them. For this one, we're going to choose, I believe we did SIDAC. So we're going to choose SIDAC here. We're going to hit continue. And what we're doing here will become apparent very, very soon. But just so it's included in our first test, we go to post hoc analysis. That means after the fact. And we have a bunch of ones here. The ones that are most often used are Bonferroni, SIDAC, and Tukey. This is Tukey's honestly significant difference test. And actually, let's not choose SIDAC. Let's choose Tukey. I believe that is what I have in the notes. So we'll choose Tukey. And this is one where you don't want to choose them all. Because again, you'll end up with 80 pages of output. And then before we hit continue, that significance level over there, what you want to do is you want to put alpha into that, your alpha into that significance level. So our alpha is 0.05. That's the default. It's already set up for us. If we had an alpha of 0.01, we would want to change that. But we have an alpha of 0.05, bless you. So we're going to keep it as 0.05. And what this is going to do is it's going to give us a double check. SPSS is going to back up our analysis, and I'll show you how that works when we get to the output. All right, so once we're done, we got Tukey, we got a significance level of 0.05, we hit continue. Now we have everything correctly set up, so we can hit OK. And SPSS goes and runs our ANOVA. All right.
Before you go on.
Yep.
I was missing something while you were doing it. Stop the step before post hoc. Is there something in options?
Options, you want descriptives. Post hoc, you want Tukey. Yeah, so you just want the descriptives.
Awesome.
Yep. So you want Tukey right there. I'm going to keep that 105. And then you have your options for your descriptives. Okay. All right, so we have our output. So now we got to read our output and make sense of what SPSS has just calculated for us. All right, so we're all done with running SPSS. So let's see what it all means. So first off, we're going to start filling in our 5 steps. So we already got the null hypothesis and we got the research hypothesis. Next thing we need to know is we need to go know our comparison distribution. And for an F distribution, your comparison distribution is defined by 2 degrees of freedom. So we have our degrees of freedom. Let's zoom in here. Actually, before we get to step 2, look at the descriptives up here. Because we're numbering these groups, just 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, 3, it is so easy to go one group, one subject too many in one group, which leaves you one subject too few in another group. I've done that hundreds of times. So what you want to do, for sure, take a look at that top table there with your descriptives. Make sure your numbers are correct in each of your groups. So we have 6 birds in each group. SPSS is telling us, yep, I got 6 birds in each group. Take a look at the means. Make sure that you haven't made a mistake there. SPSS is telling us the mean for the first group is 15. Double check that in your Excel sheet. The mean for the first group is 15. So that just gives you confidence and a double check to make sure that you entered in the data correctly. So that's why we asked for the descriptives. That's about it that we're going to do with those. We just wanted to make sure that we entered those in correctly. All right, next thing we do. Now we need to know our comparison distribution. So for the comparison distribution, we need to know our between groups or our within groups. That is the same thing as between the between variance and the within variance, right? So you might see between groups, you might see between subjects. It's the same thing. It's the between and the within. That is the big issue. So we need our between groups degrees of freedom. We need our within group degrees of freedom. That is right there. So we can fill in our between groups is 2 and our within groups is 15. So those are the degrees of freedom. That defines our comparison distribution. Next step is our alpha level. We got that from the question, alpha level of 0.05. So once we have that, we're on to step 4. Oh yeah, that's the word I was looking for, treatment. So within treatments, within groups, same thing. Between treatments, between groups, same thing. The key thing you're looking for is the between and the within. It's about 50-50, whether they're going to be called one or the other throughout your statistical career. So just that's why I don't even have it written. It's between and within. So just bear that in mind. All right, so now we're at step 4, and we need step 4 to get that p-value. So if your p-value is less than your alpha, accept the research hypothesis and reject the null hypothesis. This has not changed. So this is the exact same slide that I've had for every single t-test that we've done. Stays here with the ANOVA. If your p-value is less than your alpha, we accept the research hypothesis and we reject the null hypothesis. If the p-value is greater than alpha, we accept the null hypothesis. We say there's no difference in brain sizes, and we reject the research hypothesis. So let's go get that p-value. Very nicely, SPSS does not have, ANOVA does not have a lot of things labeled significance. It's down here in this ANOVA table, and that is your F statistic, much like a T statistic. So when you're doing your homework, it might ask you for your F statistic. That is where you find it. So this F statistic, we got 19.286. And you'll notice that we have these 2 open brackets here. This is where you write your degrees of freedom. So much like a T statistic, we would write the degrees of freedom here. This is where you write it, and it goes between and then within. So it'll always be the smaller number and then the bigger number. That's just the way it works out. So it goes between, then within, and there's our F statistic. This F statistic on the comparison distribution will leave a certain proportion in the tail, much like we had with the t-test. And the proportion that it's going to leave in the tail is that significance right there. So in this case, we get a significance that's so small, a percentage that is so low that SPSS can't display it. So this is good enough for our purposes. Our p-value is 0.000. We'll use that for our reasons. All right, so we got a p-value 0.000. If your p-value is less than alpha, you accept your research hypothesis, you reject the null hypothesis. Our p-value is definitely less than alpha, so we're going to conclude that we accept the research hypothesis. On the other hand, if it was the opposite, if our p-value was greater, then we would reject the research hypothesis, accept the null hypothesis. As I mentioned, we got a super small p-value. Importantly, less than our alpha value, so we reject the null hypothesis, and we conclude that at least one brain size is different for birds that migrate different distances. All right, any questions so far? Okay, so this is an interesting result, but notice that all it tells us is that there is a difference. But it doesn't tell us where the difference is. It says at least one of the brain sizes is different, but it doesn't tell us which one. And if ANOVAs ended here, that would make them pretty useless. So can you imagine that you leave here and you work for a clinical psychologist, and they're doing a new study on 3 different drugs to treat depression. and they have drug A, drug B, drug C, and they have a placebo. And you run the experiment, and you analyze the data, and you come back to the project supervisor, and they said, have you run the data on our clinical trial of drug A, B, and C? And you go, yes, we have. And they go, and you're like, great news, significance. We have a significant value. At least one of those drugs is better than the other ones. And they're like really excited, and they go, oh, great, which one? And you say, I don't know. I don't know which one it is, but one of them is better. Isn't that great? Well, it's great, but it's incomplete, right? So that's what we have right now. We have it that one of these birds, at least one of them, at least one of these populations, does have a brain size that's different, but we don't know which one. So to answer that, this is when we interpret the post hoc analyses. So this is when we figure out, is this significant difference? Is this at least one population that's different? Is that due to the fact that non-migrating birds have different brains than short distance? And or is it due to the fact that non-migrating birds have different brains than long distance? And or is it due to short distance migrating birds having different brain sizes than long distance migrating birds? This is where we figure it out, and this is where we interpret our post hoc tests. So that post hoc test that we did, that Tukey button that we selected, this is where it pays off. This is where we now interpret those post hoc tests to get a full understanding of what the ANOVA is telling us. So again, the ANOVA has told us with the p-value, there is a difference. The post hoc test will tell us where is that difference. All right, so for this, we go to the post hoc tests, very nicely labeled post hoc tests. And then also very nicely, notice that it reminds you which post hoc test you actually did. So if you can't remember which one you did, there's three really popular ones. There's the Tukey, honestly significant difference. There's SIDAC, and then there's Bonferroni, the San Francisco treat. And either one of those three, those are the main ones that we're going to use. And sometimes you'll forget, right? So it's nice that right there, SPSS is saying, hey, by the way, you did a Tukey. So now we have to analyze this to figure out which one of these were different from which other ones. All right, so we're doing the Tukey. And the way that this table is organized is a little bit confusing because of two things. Number one, it's completely redundant. This table is twice as big as it needs to be. So it's going to compare non-migrating birds to short-distance migrating birds. And somewhere in the table, it's going to compare short-distance migrating birds to non-migrating birds. It's going to compare non-migrating to long-distance and long-distance to non-migrating. So don't let that throw you off. You don't need to use the whole table. You're only going to be using about half of it. So it's about twice as big. It's redundant. It's got that on the table. The other thing is that as redundant as it is, for some reason they wanted to save on like a little bit of, I guess, ink when this was being printed up. And you'll notice that here we have group 1 being compared to group 2. And then here, right underneath it, we got space. Space being compared to group 3. That is still group 1. So just bear that in mind. Right here at the bottom, we got group 3 being compared to group 1. And then, I don't know why they just didn't want to write another 3 there. That space is group 3 being compared to group 2. So just bear that in mind as well. If you want, just kind of make a note somewhere. And that's the way that the table is laid out. So, first column there, we have which group is being compared to which other group. The second column there tells you the difference between the two groups. It tells you the difference between their two means. So for example, the mean for non-migrating birds, their brain sizes was 15. The mean for short distance migrating birds, their brain sizes were 9. The difference between them is a score of 6. So that's what's in the second column there. The big column for us is going to be that fourth one there, that significance. So that is going to indicate whether or not the difference is actually significant, whether or not these two populations are actually different. So that's going to be our most important column. All right, so let's start analyzing this table. First one we want to take a look at are non-migrating birds. Are their brain sizes different than short distance migrating birds? And you'll notice that here, we don't have anything that says non-migrating. We don't have anything that says short distance migrating. We got 1s, 2s, and 3s. This is where this comes back. All right, so rather than having to hang on to this in your working memory this entire time, write it down, because when you get here and you're juggling all that other information, you're going to be glad that you said to yourself, wait, what was number 1? Oh, non-migrating. And what was short distance? Short distance was 2. So I want that first row when I'm comparing non-migrating to short distance migrating birds. So we got that first row. That is literally like a t-test that is telling you, is there a difference between these two populations? The significance there, 0.003. Because that is less than 0.05, because that is less than our alpha level, we reject the null hypothesis for this comparison. We reject that there's no difference between the two, and we accept that non-migrating birds do have different brain sizes than short distance migrating birds. And remember that I mentioned SPSS will double check this for you. If you take a look at this little asterisk, it says that your mean difference is significant at the 0.05 level. That level will be whatever level you entered into your post hoc analyses. So when that window popped up and I said, let's make our, let's put our alpha level in here for the significance level, that's the 0.05 that we put in. And notice, there's a significance that indicates that it is a significant difference. And notice the little asterisk right there. That's SPSS double checking our analysis and saying, you know what, yeah, I agree, there is a significant difference there. So we got a significant difference between non-migrating and short distance migrating birds. All right, so now we know that one of the differences that was picked up in the ANOVA is that non-migrating birds do not have the same brain size as short distance migrating birds. Non-migrating birds have bigger brains than short distance migrating birds. Next one we want to know is we want to compare non-migrating to long distance migrating. So we look at our notes here. Non-migrating is 1. Long distance migrating is 3. So we need to compare group 1 to group 3. That is that column right there. So again, that space is group 1 because it's in the group 1 kind of double row. So that's group 1 compared to group 3. Mean difference of 9. Importantly, there's our p-value for that comparison. That is less than our alpha level. So we reject the null hypothesis and we say there's a significant difference between non-migrating and short distance migrating birds. And if you look at the asterisk right there, SPSS agrees. So that's that SPSS double check that you can use. So we now know that there is a significant difference between non-migrating and long distance migrating birds. So we got one more to do. We got to compare short distance to long distance migrating birds. So we look for short distance group 2 versus long distance group 3. We got that right there in that row. And we go over here to the significance level, and it's a p-value of 0.138. That is greater than our alpha level. That is greater than 0.05. So in this case, we fail to reject the null hypothesis. We accept the null hypothesis. We say that there is no difference in brain sizes between short distance and long distance migrating birds. We go over here to the mean difference. Notice no asterisk. SPSS is saying, yeah, double checked it. There is no significant difference here. So that is the final analysis we need, that short distance migrating birds have the same brain sizes as long distance migrating birds. So in the end, it looks like if you're smart enough not to migrate, you're not going to migrate. But if you cannot find food where you are, it doesn't matter how big your brain is, you're going to go short distances or long distances. The key difference is between birds that don't migrate versus birds that do. All right, so that is what I wanted to cover today for the ANOVA. Any questions on that? All right, we're all good? Okay. So just a few more things before we turn it over to practice time. Number 1, we got homework assignment. Number 14, this is your final homework assignment. This is on chapter 10. You're now ready to do this. This is going to be due April 24th by midnight, so no real big difference there. But this is where certain things start to occur. So the Chapter 10 post-test, that is going to be due Monday, April 29th by 12:45 p.m. So it's going to be due by the middle of the day on Monday, April 29th. That is so you can get your feedback and then have basically just under 24 hours to get that feedback so that you can prepare for your exam that is on the Tuesday. So just bear that in mind. We got that post-test being due at a weirder time. And then the pre-test, your pre-test My Study Lab points, if you want to earn those, if you want to get 100% on your Chapter 10 pre-test, you have to finish your study lab, My Stat Lab study plan, earn those mastery points by midnight on Monday, April 29th. So midnight the day before the exam. All right, and there's just one last thing, or actually, sorry, two last things that I want to mention. Number one, we do have a little bit of extra practice here for ANOVAs. So there's a practice problem in that Excel sheet that has to do with keyboard design. So there's the information. It's in your PowerPoint files. There's the information for your for running your ANOVA, and I will let you know in the exam which post hoc test to do. Your homework as well will tell you which test to do. So be on the lookout for that information. Give this a shot. It has the output that you should find. It also has the conclusions that you should make and the post hoc analyses that you should do. So that's there for you to test that with. And one last thing before we hand it over to practice time. I wanted to show this before, but it slipped my mind. I have also uploaded an exam, final exam 4 template. So your final exam is going to be nothing else besides confidence intervals and ANOVAs. So the confidence intervals are going to look exactly like the homework assignment that you did, exactly like that Excel sheet that you did for your homework assignment. That's what it's going to look like. So once again, you're going to read the description, decide what kind of a t-test do you need to do in order to calculate these confidence intervals, and then put them in a format where it's your point estimate plus or minus the width of your interval there. So again, exactly like the homework, half of your exam is going to be confidence intervals. The other half of your exam is going to be ANOVAs. So for the ANOVAs, you'll have your description in order to kind of set up the ANOVA. Notice that we've only done one ANOVA, so you don't even have to decide which ANOVA is the right ANOVA to do. We only know how to do one, do that ANOVA. What's important here, though, is that here's your alpha level, and I will also tell you what post hoc analysis to do. So I will say, hey, do a Tukey, honestly significant difference. Do a SIDAC, do a Bonferroni test. And then your challenge is going to be, number one, to take your data and format it in SPSS in a way that it can run this data. So we know that all of these have to go on their own rows, and they all have to be labeled with numbers to identify the groups. So that's going to be your first challenge. And then what you're going to be doing is you're simply going to be filling in the steps. Now, because of the weirdness with the null hypothesis and the research hypothesis, I will fill that in for you. So the null and research hypothesis will be given to you. So much like I have it here, I will have the null hypothesis sitting there for you, and I'll have the research hypothesis sitting there for you as well. What you need to provide is you need to figure out the degrees of freedom. So in your ANOVA output, what's the degree of freedom for between? What's the degrees of freedom for within? You have to tell me what's the alpha level for the test. Merry Christmas. You have to give me the p-value that you find. So again, your p-statistic as SPSS calculates it. And then based on that p-statistic, you need to let me know if you accept or reject the null hypothesis. And for the research hypothesis, once again, they have to be different in order to get full points. And then finally, the last thing you're going to need to do is you're going to need to interpret those post hoc analyses. So I will ask you for specific comparisons. I will say something like, are the BLA-W patients different from the BLA-X patients? So is there a significant difference between BLA-W and BLA-X? All I need you to do is to go to that output table. If there's a significant difference, you would put yes into your answer column. If there is no significant difference, you would put no into your answer column. I will not ask you for all the comparisons, because in this case there would be, there would be 6 total comparisons. You can get out of hand sometimes, depending upon how many levels you have. So make sure that you identify the comparison that I'm looking for, find it on the table, read the p-value. If it's less than your alpha level, there's a significant difference. If it's greater than, there's no significant difference. Double check it with the asterisk, and that is your entire exam. You'll have half of it being ANOVAs that you have to run, half of it being confidence intervals. Question?
We don't need to put anything to do with the F for the test at all?
Yeah, so for the test, we won't ask you for the F statistic. I showed you that because your homework probably will ask you for the F statistic. But really, the decision is all based on the p-value and alpha. So that's what we'll be looking for. All right, any other questions about anything that we've introduced today? All right, so that is it for basically what I wanted to cover this semester. So if that's enough for you, if that's enough stats for you today, feel free to head on out, call it an early day. Other than that, we got about 25 minutes left for practice time. So get a jump start on your homework if you like. Try that extra practice problem if you like as well. And call me over if you need any assistance, and I'll come by and I'll give you a hand.